Hey guys, welcome to the lesson. So in this lesson, I'm going to share with you question number 20 questions definitely from question number 21 to question number 40. Okay, if you're watching this video the first time, then you must watch the first section, first lesson of this series because it will help you to grab some new concept from those videos too. So let's get started, right? And let's say what we have given in this question. Which equation clearly defines the entropy change during the isothermal process for a system with m kg of gas at pressure P1, volume V1, temperature T1, entropy S1 is heated to state point of pressure P2, volume B2, temperature T2 and entropy S2. So we have given options, four options, but let me tell you the exactly concept we required. We know that ds is equal to what? mcv natural log T2 by T1 plus mr natural log V2 by V1. We know this formula, right? Let me share with you a trick to remember this formula because very often we forget these formulas, especially in case of entropy, because there's so many things, right? So the trick you need to use to remember this formula, that is what, my dear? Here V and T. V for what, my dear? Just listen to me very carefully. I have created a slogan for this, right? So I'll write that. That is what? Vivek, right? Tiwari, Tiwari. Vivek Tiwari. And so V for Vivek, T for Tiwari, and Ram Burma are friends. R for gas constant and V for Burma. So Vivek Tiwari and Ram Burma are friends, right? So in this way, what will happen whenever you forget, you can easily remember the formula. And one more thing, for both the cases, it is given T2 by T1 by V2 by V1. I mean, there is T2 by T1 and also we have V2 by V1. I hope you remember this. Now, the process we have given, that is what, my dear? Isothermal process. That means in this case T1 by T2. So whenever natural log T1 by T2 if we put T1 by T1 if we put, that means natural log 1, and the value of natural log 1 is what? 0. Therefore this term will become 0. So we got the answer for this question is what? This one. So if we'll see the option third, let me show you exactly the option third what we have find out after solving that equation. So option third is the correct answer for this question. Let's move on to the next question, that is what? In a PV diagram for pure substance, the constant temperature line in superheated region is. So let's draw the PV diagram, right? We have to draw the PV diagram, and it is saying for the pure substance. So it will be like this and it will be like this. So in this case, the constant pressure, constant temperature line, temperature constant, right? So these lines are diverging lines. Diverging means away from each other. Converging means just coming, they're coming together, right? So this one is converging and this one is diverging. So option B is the correct answer for this question. Let's move on to the question number 23rd, right? What we have given. The entropy change of the system and surroundings during a process between two equilibrium states is, right, equal to 0, greater than 0, less than 0, greater than or equal to 0. Now, entropy change of a system, right, of a system in this case can be greater than 0 or equal to 0, right? Because it is like this, we know this, right? So these two options we have given in this case, so it is relying on this only, that is what? ds is greater than equal to 0. If it is less than 0, right, which is not possible, which is impossible in case of our system, right? So option D is the correct answer for this question. Let's move on to the question number 24th. What we have given. A Carnot heat pump is used to maintain a room at a temperature of 30 degrees centigrade. The initial temperature of the room was 10 degrees centigrade. if the power required in the pump is this much 20 kilowatt, what is the heat supplied or heat pumped, right, into the room? So for this, my dear, we have to we have to draw a diagram of heat pump. Let me draw the diagram, right? So this is heat pump, right? And we have to draw like this. Oh, okay, there is a mistake. Okay, it is heat pump, right? So heat pump, so the arrow should be opposite of heat engine, so it will like this, and this is work done, right? So we have given 30 here, no, this should be 10 here and 30 here. This one is how much, my dear? 20 kilowatt, and we have to find out this one, right? So in the COP of heat pump is equal to how much? TH by TH minus TL. So what is the value of TH? 30 plus 273. TH minus TL 20. So what is the value we are getting? If I will use the calci. So value we are getting 30 plus 273 division 20. So it is 15.15, right? Or we know that COP is equal to what, my dear? In case of heat pump, heat rejected by work input. So we have given work input, we have to find out heat rejected, that is here. What is the heat here? We have to find out in kilowatt. So we can write heat rejected is equal to work input multiple COP. So what is the value of work input? 20. So 20 multiple 15.15. So answer we are getting, that is what? 303. So option D is the correct answer for this question. I hope you understood the whole concept. So I would recommend you always solve the problem by yourself. It will help you a lot. Now, next question we got 25th number question. Which equation best represents the net entropy change for an irreversible process? So we know that in case of entropy change, we have standard like this. We have standard relation like this. So ds is greater than 0, which is what? Reversible process, and ds is equal to 0, which is what? This one is not reversible, this one is irreversible process, and this one is what? Reversible process, right? So it is saying irreversible process, so ds is greater than 0, what? Irreversible process. So therefore this should be the correct answer, D. That means S entropy should be greater than 0 in case of irreversible process. For reversible, ds equal to 0. So option D is the correct answer for this question. Now let's move on to the next question, that is 26th number question. According to first law of thermodynamics, which of the following equation is correct? We have given option. So we know that in case of first law of thermodynamics, cyclic change dq is equal to cyclic change of the total work done. That means dq is equal to dw, cyclic change for both the cases. So option B is the correct answer for this question. Let's move on to the 27th number question. Which equation represents the steady flow system, right? So we know that in case of steady flow system, what we have given, let me just write down, enthalpy, kinetic energy plus potential energy, right, plus q. So this one 1 1 1 is equal to what? Enthalpy, kinetic energy 2, potential energy 2 plus w plus losses. So this is the formula, right? So if you will see the question, option number 3rd, it is directly matching with this formula. So option 3rd is the correct answer for this question. Question number 28. In a PT diagram for pure substance, the melting line has highest inclination with respect to positive horizontal axis represent temperature for which type of substance? Okay, so this type of concept we got from PVD diagram, right? So in case of PVD diagram, we have solid surface diagram we can draw. Otherwise we can draw, my dear, PT diagram and PV diagram. So here it is talking about what? PT diagram. So let me draw that diagram, that is PT diagram. So it is P and T. All right, so this is diagram, this is showing the PT diagram, right? Now let me draw other things of this PT diagram. This one is sublimation, this one is evaporation, this one is melting, right? Melting or fusion, this is evaporation. So what is happening? Let me draw it like this, because this should be little bit like this, right? So this is positive slope, but it is showing highest inclination line. So it is showing, my dear, like this, as I have shown right now. It is having highest, but it is having negative slope. So there are for all the substances, slope would be positive except only one, that is what? Water. And because of that, what is happening in case of water, whenever it is freezing, water expands. That's why ice float on water. It is floating, it is not going inside, it is not dropping, my dear, right? Except other things, only water is expanding when it is freezing, others are contracting. So water is having this amazing property, and because of this property, aquatic animal can freely move, right? So option B is the correct answer for this question. All right, so question number 29th, what is saying? Work done by a system is 45 kilojoule. If the internal energy of the system is decreased by 15 kilojoule, what is the heat received in kilojoule by the system? So we have to find out heat received, right? Now we know that dq is equal to what? dq is equal to du plus dw. So work done by the system is what? Positive 45 kilojoule, and it is saying decrease, that means there should be negative sign, 15 kilojoule. So after simplifying this, what we are getting? 30 kilojoule. So option C is the correct answer for this question. Question number 30, a reversible adiabatic in a TS diagram is a. So for this we have to draw a diagram, TS diagram, right? So in case of VCRS, we have like this curve, and this one is 1 to 2, and it is what? Reversible adiabatic. So from 1 to 2 the process is going on. In this case, what is going on, my dear? It is a vertical line. All right, so it is reversible adiabatic means what, my dear? Isentropic. That means what is the meaning of this? Entropy is constant, right? Now let's move on to the question number 31. What it is saying? Specific enthalpy is an, so dash property is saying, and its unit. So enthalpy is what, my dear? It is an extensive property, but a specific term is coming because enthalpy is an extensive property. So extensive by specific means divided by mass. So mass is an extensive property, enthalpy is an extensive property. So we know that extensive by extensive is what? Intensive property, right? So what is the unit of enthalpy? Enthalpy is a kind of energy, it is a stored energy. So its unit is kilojoule, and because we have divided this by mass, because a specific term came, so it will be, my dear, kilojoule per kg. So according to all the options we have given, if you will go through it, so option D is the correct answer for this question. Question number 32, this is a superb question, amazing question. The internal energy of the system is a function of temperature only. U is equal to 30 plus 0.5 T kilojoule. If the system does the work 0.5 kilojoule per Kelvin, what is the increase in heat interaction per degree temperature? So in this case, what we know, my dear? We know basically dq is equal to du plus dw. Now we can divide all the terms by dt. Let's do it, dt. So in this case, what is happening, my dear? We have to find out this, because it is saying that per degree temperature. So whatever we have written, it is correct. So we have given this work done, we have given per degree temperature, that is 0.5. We have to find out du upon t. Let's differentiate this term with respect to t. So this 30 will become 0 and this term will become 0.5. So what is the value we are getting for du by dt is equal to 0.5. So 0.5 plus 0.5 is what? 1, and unit would be what? Kilojoule per Kelvin. So option C is the correct answer for this question, and this type of problems, my dear, we usually see in case of different company examination. So you must understand this, right? Question number 33, right? What we have given? 2500 kilojoule per minute heat is supplied to a heat engine at 727 degrees centigrade. It rejects heat at 900 kilojoule per minute at 2 to 3 degrees centigrade. This type of engine is ideal, irreversible, impossible, practical. So my dear, for this case we have to find out efficiency of heat engine for both the cases by using temperature as well as by using heat. By using heat we got actual efficiency, and by using temperature we got maximum efficiency. So from that relationship, what relationship we can find out after finding out efficiency for both the terms, temperature as well as heat, we can say what type of engine is this: ideal, irreversible, impossible, or practical. Okay, so and maybe practical, right? So let's find out efficiency in terms of, my dear, in terms of temperature. So we know that efficiency of heat engine is what? TH that means higher temperature, TL by TH. Now I am using calculator, so always add my TH minus TL, 727 minus 223, division 727 plus 273. What is the value we are getting? That is 0.504. Now let's find out the efficiency in terms of heat. So what is there, my dear? Output by input, that means W by Q1, we can say that. But here, my dear, heat supplied is what? 2500, right? And what is the output, my dear? Because it is rejected, it is supplied, so difference between both the term, we are going to get output, right? Because this one is supplied and this one is rejected, so difference between both the term will get output, that is W. So what is the difference between 25 and 900? That is 1600. So here we can write 1600, right? So now we have to divide 1600 by 2500. So what is the value we are getting? 0.64. Now just compare both the values in terms of heat and in terms of temperature. So according to the concept, we know that in terms of temperature, if you got the value of efficiency in terms of temperature, then we must say that this is a very good, I mean, practical cycle, right? But practical heat engine. But it is here, my dear, if you are seeing in terms of heat, we are getting more efficiency than in terms of temperature, which is not possible. That means answer for this question would be what? Impossible. Question number 34. What happens to COP of a heat pump when temperature difference between source and sink it is decreased? Now we have to write COP of heat pump. COP of heat pump is what, my dear? TH by TH minus TL. Always write COP of heat pump. It will help you to be not confused, right? Because confusion is very harmful for our computer examination. Now let's just use this concept. Whenever this difference will increase, definitely this term will decrease. That means COP will decrease. If it is decreasing, COP will increase. So in this case, what is happening, my dear? Option D is the correct answer. Even you can find out by using values, right? Okay. Now question number 35. Well, this question is really common question, right? In case of thermodynamics, what we have given: if Carnot engine CE1 and CE2 are connected in a series such that heat rejected by CE1 is used as heat input for CE2 cycle, with the intermediate temperature being the geometric mean of the extreme temperature, which of the following statement is true for this efficiency of the Carnot engine? So my dear, just look at this geometric mean. That means it is saying T2 is equal to T1 multiple T3 power 1 by 2, and this can be possible only if efficiency both the engine is equal. If work done for if work done, we'll find out, my dear, in case of other engines, but here, my dear, the efficiency we are finding, right? And if we'll say work done for this case equal, right? Let's say W1 is equal to W2 for both the engines, then we can say intermediate temperature is equal to T1 plus T3 by 2, right? All right. So question number 36. What type of slopes does constant pressure line have in the superheated region of the Mollier diagram? What type of slope we have, right? So let's draw a Mollier diagram, that is Mollier chart, HS diagram, enthalpy entropy diagram. So it will be like this, the constant pressure, right? And this is what, my dear, positive slope, we can say that it is like positive slope. All right. So option A is the correct answer for this question. Let's move on to the question number 37. For a gas with n degree of freedom, what will be the value of Cp by Cv? Now this is an amazing question, and this question needs time to understand. So let me show you the derivation to find out this question, right? And one suggestion I want to give you: whenever you're getting this question, if you don't know the answer directly, don't derive. Otherwise you will just you have to invest a lot of time in the computer examination. So we know that E is equal to what? N by 2 RT. What is N here? Degree of freedom, right? And we know also Cv is equal to curly E by curly T, and Cv means volume is what? Constant. So after doing, if we'll use the concept that curly, if we'll differentiate this term, what we're getting, my dear? N upon 2 R, because this T will be 1, so N upon 2 R. So Cv we got, right? Now we know, my dear, what? Cp minus Cv is equal to R. Therefore Cp is equal to Cv plus R. So what is the value of Cv we got? That is N by 2 R plus R, right? Now we can take LCM too. So we can also take a common, that is R. So it would be 1 plus n by 2. We can write like this. Okay, I hope so you're getting me. I think so there. Okay, now take LCM from 2 from here. So r by 2 and 2 plus n would be the right way to write this equation. All right, now we know that we have to find out Cp by Cv. We know that Cp by Cv is equal to, we can find out, right? Now we have to put the value r by 2 n plus 1 n plus 2, not 1, I'm sorry, and this will be n by 2 r. So r cancel out, 2 cancel out. So what are getting, my dear, what is the value we are getting here? N plus 2 by n. So we can write this this one after simplification, 1 plus 2 by n. As you can see, the option D is the correct answer for this question. This is an amazing question, isn't it, my dear? This is a very good question, I think so. Yeah. Now guys, let's move on to the question number 38. A refrigeration system works on. So there are two statements we study after second law of thermodynamics. Obviously the answer is second law of thermodynamics, but let me tell you couple of things extra we should know. So there are two statements. One is what Kp, that means Kelvin Planck statements, which gives the concept of what heat engine, and another is what Clausius statement, which gives the concept of what refrigerator and heat pump. All right, so this is very, very important, right? Yeah. Question number 39. Liquids have, okay, so there are two things we have. If you go through the options, one is specific heat, right, at constant P, pressure, and another one is what specific heat at constant volume. But in case of liquid, my dear, we have only specific heat at constant pressure, that is Cp. Liquid, let's take an example. Water is having only Cp, right, 4.186, but in case of air it is having Cp as well as Cv, right? So I hope you remember this. All right, so question number last. Well, the volume of the universal gas constant Ru is equal to, so I mean this is a value, my dear, there's nothing else, right? So answer for this question is what, this, that is 848 meter kg mole per Kelvin. So that's it for today's video, my dear. Thank you very much for watching, and I hope you're enjoying this video. So like the video, share with your friends, and we have done question number, my dear, question number 21 to 40 number question. In the next class we'll discuss 41 to 60 number question. And thank you very much for watching. See you soon in my next video. Bye bye.